Good morning, GraphQL Summit, day 2. Welcome, everyone. It's very cool to see you all here. I was really worried that we'd all sleep in. So this is much better. We're off to a good start. As Becky said, hi, my name's Jed. You might recognize me from the internet as Jed Watson. And I co-founded this company in Sydney we're called Thinkmill. Thinkmill, we mainly make software. We produce code, and we've spent a lot of the last 2.5 years working with Atlassian. We started out helping them with their design system, but we also moved into a lot of other React UI code. And recently, for the last year, I've been helping them out with Jira. Who's used Jira? Yeah, I thought that might happen. If you're using Jira Cloud, you might have noticed at some points in the last year it's actually gotten a lot faster, and it's become more and more a true SPA. Those huge, clunky, full-page refreshes aren't there anymore. And that's something that I spent quite a bit of time helping out with, sort of as a guest front-end architect. And that was a pretty classic transition from a Java monolith to a fully modern SPA by way of rebuilding a lot of the UIs piecemeal in React. And this has been quite a challenging project because Jira is actually quite a lot of different apps being worked on by different teams. There's a lot of engineers involved. And the challenge once all of that has been kind of transitioned from these old Java templates into modern React UIs to get them all to kind of sync together and feel like a unified app and really that true modern SPA feel. And that has led me to what I'm here to talk about today, which is one of the biggest challenges we had on that journey, state. So this is a treatise on state, which is the title of the blog post that I published internally, and a lot of thinking that came together to sort of make the synchronization of all of these different apps that were being written by different developers concurrently possible. And a treatise on state is a bit of a mouthful, so you could also think of this as just how to think about state. Right? Often if we're going to work with something well, it helps to just get a good grounding in how to think about it, and then the problems are a lot easier to solve. So I'm going to try and answer 2 questions for you today. The first is, what is state? And the second one is, how do we manage it? I'm not sure that I'm actually going to answer these for you because they're both very, very challenging questions. I think this is almost like a life's work, right, as a front-end or a back-end developer. But we'll see how we go. Let's start with the first one. What is state? You might have seen this before. If you've worked or even seen React at all, this is probably pretty familiar to you. We spend a lot of time on the view side of this equation and the whole idea that state is a view is a function of state. But what actually is the stuff on the left? What is it made of? Let's spend some time thinking about what actually goes into that bucket that we're generating our UI from. This is a really hard question to answer because it's going to be different on every app. So I took a step back and started thinking instead, maybe we can define the rules of state. If we can identify the rules of something, then we have a bit of a better chance of actually identifying what it is. And so I actually spent quite a bit of time thinking about this and came up with this answer that applications have 5 types of state. And here they are. So this may not be the same for everyone. Everyone that I've spoken to about this has kind of challenged me on edge cases and, oh, what about this kind of state, or what about these ones? And that's okay. Like, this is not meant to be a pedantic categorization. I'm not a scientist. I build applications. I ship them. This is about giving you a framework to think about these different types of state in a particular way so that you can actually carry this forward and start conversations with your team or start actually thinking about this and developing it further. Now, before I go into what each of these different types of state are, I'm going to cover a quick concept that's going to thread through the rest of the presentation, which is components. So back to this idea where our view is a function of our state. What we can do in modern front-end frameworks is bundle that together so that we have these building blocks of state becoming view, and they are our components. This is a bit of a new primitive, if you will. This is actually one of the big differences that's really fundamentally changed web development in the last 10 years is the advent of systems that let us truly work in components. So the biggest, I think, conceptual shift that we've had to get through on the front end in the last sort of 10 years has been this huge transition from working on web documents to web applications. And at the same time, we've gone in a pretty clunky way through working with markup as our primitive, through by way of jQuery components and a whole lot of other stuff, to components as our new primitive. And this is actually really neat. I'll come back to this a bit more later in the presentation, but the other thing is that components aren't limited to their own state. You can actually create a hierarchy out of them, and that's what makes them so great, because you can feed them in state from sort of above. You can pass that state down to other components, and you can also provide them callbacks to call when state should be changed. And this is really the core of a composition model that is changing the way we build front end. So with that components concept out of the way, I'm going to look at a component. This is a pretty simple one. This is a select. I'm actually being a little tongue-in-cheek here. Selects are quite complicated. I gave a talk at ReactConf last week on just how complicated they get, but we'll keep it simple for here. This one, it has a few different types of state in it. For example, the menu is open. That's a type of state. If the user was to start typing into the input to reduce the number of options they had to pick from, that's another piece of state. And once they've selected one of those values, this is another piece of state. So we've got 3 little pieces of state that are being managed by this component. That's all good. Right, this is that first type of state, local state. Now we might take this select field and put it in a form. Now our form is going to have some state about what the values of all of its inputs are. That's also local state, where we'd now be using that pattern of props and callback to pass down from the form to the select, the value, and call back to the form when the select is changed. So this is local state. And the kind of guidelines for local state use it for things like component state, form state, keep a local copy of something before you submit it and do something with it. And also various different UI state, like the fact that that menu is open or closed. Now, local state is your best friend as an application developer. This is pretty much always where you want to start. And you pretty much always want to start by passing it down to other components through props. It's a nice, easy way to start. But let's have a look at when things get a little bit more complicated. Let's go back to our form. And now we'll put it in an application. And let's stop focusing on our form for a second, and we're going to have a look at the header. Now we have a header component, and like all good header components in applications, this one's going to have information about the fact that I'm signed in. It's going to have some little widgets up there, maybe my avatar icon. Now that also could be local state in that header component. I could load up that information and render it. But what if I need these fields in my form to also maybe offer the user different selections based on who they are or what they've got access to? Now suddenly we have 2 components on the same page that want to access the same piece of state. And this is your clue that we've found some shared state. So what we do in this situation is we'd actually progress from using local state in our mental model of our app to kind of hoisting that into this container around the app, this purple one. And then we'd provide that state down to these 2 components. Let's have a look at shared state. This is typically used for things like application state or data that is shared across the application, like a cache or a store, as well as shared concerns in the UI state. You might want to know, is there a modal open? Should we pause background processing or anything like that? The key to shared state is not to always assume that it's what you need, but to go here when you know why you need it. So when we're looking at that UI, we saw, okay, now we have state that needs to be accessed by 2 components. That's shared state. And let me break down for you the rule that we've developed around how to identify this. Transition from local state to shared state when you have 2 or more components that need to access or manipulate the same piece of state, but should have no knowledge of each other. And this is sort of based on the principle of least knowledge. It's not quite a direct translation of it, but the principle of least knowledge is that each component in your system should have as little knowledge about other components as possible. If your component doesn't need to know about other components, that's perfect. Make sure it doesn't need to. There's no way that our header should have known about our form, so that was where that rule came from. Now, just looking at the way that I've described local state and shared state, you might be thinking, what about props drilling? JED, come on. We know this is bad. Why are you telling us to parcelize state around with props? For those of you who haven't met props drilling yet, you're the lucky ones in the audience. Basically, it's when we have a hierarchy of components, and we've passed our state down through props, and we have all these components in the middle that are receiving something only to pass it on. And that actually gets really messy over time. But luckily, React and other frameworks have a concept of context. And the context API lets us pass something from a provider down into a consumer without passing it all the way through. And this is a very similar style of transition from local to shared state, but they're not actually the same. They're often conflated. And I want to give you a rule as well for when you want to be moving between those two APIs without necessarily triggering that local to shared state transition. So you'd go from props to context when there are interstitial components that shouldn't know about a prop, but exclusively accept it only so they can pass it on to their children. Bit of a mouthful, but it's a really good rule if you can follow that. You can kind of get your head around the idea that these two things can be managed independently. Anyway, moving on, back to this select. Let's say that we don't know what these options are before the page is loaded. This has actually got to come from a server. We've just found another type of state. And given that we're at GraphQL Summit, you've probably been wondering when I'm going to get to this. This is remote state. That's the third kind. Now, you might be wondering why is remote state different to shared state? A lot of the things that I described about shared state probably sound like ways that you'd be using remote state in your app. So here's the difference. Remote state basically plays by some different rules, and the first is that you don't own it on the UI. It's actually stored somewhere else. The source of truth for that state is a server. You might cache it, and you might derive other values from it, and you also have an API to sync your local changes back to it. But it's always async. And it's not infallible. You have to be guarded when you access it. You always have to do a lot more work and write more code in order to work with remote state than you do local or shared state. So we're starting to see these different properties emerging between the different types of state that we can work with in our app. And along with remote state, if I was to start typing into this select box and maybe wait for some results to appear, maybe there's a lot and we need to filter them on the server, this loading state, that's actually another type of state again. I struggled for months whilst explaining this concept to different teams to figure out what to call this, and we ended up going with metastate. This is state about state. Now metastate is actually, again, another set of different rules. Metastate is provided for you, and you're not the source of truth. This is subtly but importantly different from you don't own it. This is like you really don't own it, this one. Right, it exists. You can't argue with it. My request is in flight. My request has failed. My request has come back. I have my results now. This isn't the list of options I'm loading, but this is my progress towards loading that. Sometimes, depending on what it is, you might have an API to request that it changes. You might say, hey, just refetch that. You could also track things like animations, the transition from one state into another, and that would be a valid use of metastate as well. It's not just for remote requests. It's a good idea to always respect it. If your application is loading, don't ignore that. Or if your application comes out of a loading state, don't ignore that. And this is not actually part of remote state, but it is often coupled to it. We'll often see these two types of states coexisting together by the async nature of remote state. So let's have a look at our last type of state. And this is kind of a weird one to pull out, but if we have a look at this app and just put it in a browser, now you'll see we're at /create new. I would expect that, although this is a mock, this form is now going to be showing us an option to create a new thing. But because these components are reusable, we could take that form and we could repurpose it to give it some data to start with, and then we could use it on our edit screen. And maybe the difference between those two states for that form is just changing the URL in the browser. And if we go to editing thing 1, 2, 3, and we then transition to editing thing 5, 6, 7, we would want our form to respect that. We would need to make sure that any values that have been cached had been replaced. Everything else on the page basically cascades from this type of state, and this is router state. it's not just that things might change and need to update their internal state when route state changes, it's also that you could end up with maybe different components mounted on the page or different pages being rendered entirely. So route state is really like kind of king. It'll just do whatever it wants. And it behaves by very similar rules to the metastate. It's provided for you and you aren't the source of truth. You do have an API to request that it changes, but you need to always respect it. You can't control it. The user could press back, they could refresh the screen. They would expect the app to respond accordingly at every point in time. And this makes it a bit more special than any other type of state that we've managed. It is also not part of remote state, but often when you transition from one route to another, your remote state will need to update. Now, I want to show you a couple of things that can kind of go wrong when you're not following these rules for particularly router state. I'm borrowing from a real-world example here that we had to work through. Let's say that you've got this component on the left, which is a list of things you can pick from, and on the right, you have a form where you can edit the one that you've picked. Now, both of those components want to be wired up to the route state. But I'm just going to simplify this UI for a second so we can zoom in here. The thing is that if they're both managing that route state independently, they might know a bit too much. They might know about things that they shouldn't know about. For example, it might be easy to pick something on the left and have it update the URL. That makes sense. But let's say that form on the right, that save button down the bottom, that's like a save and next. And that's also got to update the location. We start to run into trouble here, right? Because we have two different components managing state that's owned by the browser. The first thing we want to do is pass in the thing that they should be working with and make sure that we respect that. So that if this thing ID prop changes, we don't want to be caching data inside of that form that's not derived from that prop. We need to be really careful about that purity. But second of all, we want to make sure that if that changes, we're surfacing that information back up to our parent. So on thing change, we want to say, set new thing to the value I was just given. Now, this has actually been the source of a non-trivial amount of challenge in a large application that I've worked on recently. And that's because this wasn't all quite wired up the way you would expect. What we actually want to say is that we don't want either of these components to be directly manipulating that state. They should just be talking to that parent. And the reason for this is, remember that form can be embedded in different places around our application. It doesn't actually know where it is. And it shouldn't have to understand the routing scheme of our whole application in order to save and next. It should just be able to say, oh, I'm done, handle that for me, please, parent component, thank you. So yeah, these kind of became really important principles when we were working on this. So those are our 5 types of state that we've identified. Local, shared, remote, meta, and route state. And that's the rules for understanding when you're working with different types of them and how to think about that. So that doesn't quite answer what is state, but I think it gives us a framework for thinking about how to identify what state is and what different types of state needs to behave which way in our app. So let's have a look at that management side now. Now there's a great quote, which I'm going to attribute in a cheeky way to Pete Hunt, because definitely for me he popularized it. I think he stole it from somewhere else, but shared mutable state is the root of all evil. Now, I didn't see anyone dressed up like this last night, but I'm pretty sure you could go out on Halloween dressed as shared mutable state and freak out a bunch of front-end developers. That's like the scariest thing I would see on the streets. The problem with this is that complex applications thrive on shared mutable state. This is actually how we do cool things. Now, not all shared mutable state is bad, actually, as it turns out. We've become much, much better at handling it. Exhibit A, Apollo. Apollo is an example of shared mutable state that's actually managed really well. And it scales really well. And it is, I guarantee you, not the root of all evil. But let's take a look back not too far in the past at another friend of ours, Redux. Now, after working on sort of front-end architecture at Atlassian for a while, I ended up doing a bunch of training sessions for different teams. And I used to enjoy trolling them with these next 2 slides because they've been using a lot of Redux around the place, and I'd say, this is your app. And this is your app on Redux. Now, the point is that I'm not actually here to bag Redux, but it's got a lot of gravity, right? It's like a black hole that wants to suck all the state of your application into a single store. And it makes no differentiation between these different types of state that I've mentioned, or the different ways in which they behave. Everything acts like local state, or shared state, actually. Everything's synchronous. Everything's in one big blob. Async state is hard to manage because you kind of got to do that manually. You've got to add all these actions and reducers for managing data is loading, data is not loading, all these different patterns for working with that. And it actually gets super complicated. It's got a couple of other flaws like some boilerplate, but look, as I said, I'm not here to bag it. It's got great developer experience for debugging and state management and a whole lot of other things. Also, it's fundamentally built on a state reducer pattern, which is an amazing solution for some problems. In fact, it's such a good solution that we got it recently in the new React Hooks API. We now have a native use reducer as part of React's API. Right, so it's not all bad. But if you look at what else we got alongside use reducer, we got use state and use context. And I think that if you saw this as your starting point, you wouldn't actually look at that and think, oh, I know what I'll do. I'll create a single reducer, stick that at the root of my app, and then run 100% of my state changes through that. That's a good idea. That's going to scale really well. It didn't. Because of that, refactoring from Redux to Apollo tends to, in my experience, reduce the lines of code and increase the clarity across an entire code base. It's awesome. I do this every time I get my hands on a code base with Redux. I'm like, oh, let's get some Apollo in here. Throw this in the bin. It's great, but why? Again, the whole point of this is to be thinking about what's actually better. Why are we seeing these effects? Well, the first one, I think we've all heard enough times to have come to a conference and hear about it. You select the data that you want, and you don't have to transform it when you get it. And that genuinely tends to be a lot of the code that I've seen written in Redux when you're dealing with REST APIs. But what else is it doing? What else has changed? Data requirements are now co-located with the components that need them. And that's really handy. That's actually leaning on that composition model that I was talking about earlier. It's much more native to the concept of a hierarchy of components that are being composed together. So it's working better with the inherent composition models of these modern frameworks that we're enjoying the benefits of. We're no longer building up our own kind of entire structure and state schema alongside that we need to manage and manually wire up. But another point that I think is kind of underappreciated is that metastate is handled for you automatically. And now that we've thought about remote state and metastate as different things, and shared and local state as more different things that all share have different properties, right? These benefits start becoming obvious as well. The fact that metastate is handled for you automatically is actually pretty obvious when you look at the API. But think about the benefit of this. Redux was designed as a synchronous store, whereas Apollo was designed from the get-go as something for managing remote state. So obviously you'd make it really easy to actually manage the metastate that goes along with that. And the other thing, just to come back to that composability point, is that it sits very nicely alongside other APIs like using local state, or shared state, or route state. And because we have this universal API now with hooks for accessing these different types of state from wherever they're most appropriate to be stored and managed, it's much easier to then kind of make this work together nicely in our application without fitting things into patterns that weren't designed for them. So let's have a look at what React says about this. Right from the docs. I love this. It's on I think page 1, and somehow we ignored it for so many years. Just build encapsulated components that manage their own state and then compose them to make complex UIs. That's the whole story. Now, I would include the concept of depending on state like you would when you're running a query in the concept of managing state here, just by the way. And what this leads us to is something I call riding the wave of complexity. Now, Who's here in the room is in a startup? Yep, there are startups everywhere. I mean, we're in San Francisco. So you'd recognize this graph. This is revenue over time. And what you're probably looking for in your startup is for it to go like this. This is hopefully a familiar experience for at least a couple of startups here in the Bay Area. But if I was to change these axes from revenue and time to complexity and features, I've probably got a more common experience for startups in the Bay Area now. This is often the experience we have when we adopt a framework early on that solves for a lot of our use cases but doesn't scale well, and then we scale. What I love about React and this whole component model is that it lets us ride a curve more like this. This is riding the wave of complexity. We can allow complexity to come in and then just sort of abstract it away behind components. We can let more come in. We can extract to more components. So we're always in control of how much complexity we're dealing with at any one point in time, because the minute something gets complex, we just stick it in a component. It's nice. It works really well. And this kind of brings me to my next point, which is that we're very good at solving problems. Sometimes we're good at solving problems that we created for ourselves. It's much better to not have to, don't solve problems when you can stop having them. Now, I'm going to draw an analogy from front-end development, just to sort of get you thinking again, state. What's state got to do with CSS? Well, we used to apply styles with class names. And then our style sheets got so big that we had to invent methodologies for scaling them, things like BEM. Now, we got to the point, though, where our frameworks and tool chains have matured, and we can do things like CSS and JS, which lets us get those styles and bundle them into a component. So our component concept now encapsulates state and styles, and it's everything we need to build a primitive building block of our application. State comes in, callbacks go out. So this thing that we did with CSS and JS is actually very similar to what we're doing with the modern state toolchain and tools like Apollo. So we all love Apollo. The ergonomics of it are great. But it's not just about picking up new tools. It's about thinking about why they're better. That gives us a deep appreciation of how to use them well. And my tips for you are always identify which component owns which piece of state, and then just wire that up to other components with props and context. It matters less which tools you use to manage state so much as how you clearly identify the ownership of that state and the rules that apply. And one size doesn't fit all when it comes to state in front end, because I think the answer to that, what is state, is well, it's kind of everything, right? It's like all the stuff driving your app. It makes sense that one size doesn't fit all of everything. And you don't have to choose a single framework to manage it either. You just need to focus on remembering the different rules and choosing patterns that are appropriate to each rule. Quick recap on those rules. Local state is for, well, little things. But start here, because you'd be surprised how much you can get away with. Whereas shared state is for when that needs to be shared between two or more components that should have no knowledge of each other. And then remote state, you don't own, but you can sort of own it. You can play with it, and it's always async. And then meta state is the state that's produced by running side effects in your application. With hooks, we can access the types of state through the same APIs. And then with components, we get a universal API for composing them together. And that's really all we need to build complex, sophisticated applications that scale. So design good APIs for your components, and then compose them to build complex things. And that's my treatise on state. I've got 40 seconds before I need to get off this stage. And I wanted to just do a quick shout out for my team in Sydney, because while we were on the plane over here, they actually launched a thing that they've been working on for about a year and a half, which is Keystone 5. This is an open source project that we've been working on for a while. It's a sort of Node.js CMS platform. You feed it schema, it wires up an Apollo server and an ORM and a React-based admin UI for you to manage data. It's kind of everything. If you're into that sort of thing, check it out. But in the meantime, thank you. I've been Jed Watson. Enjoy the rest of the conference.